Good evening, students. Today I am going to teach about the eigenvalues and the eigenvectors in the given matrix 113, 151, 311. You already know the method. I am going go through once for the sum to find the characteristic equation. The characteristic equation method is lambda power 3 minus s1 lambda square plus s2 lambda plus s3 is equal to 0. For find outing the s1, some of the main diagonal elements, we have to add the 3 of the main diagonal elements. 1 plus 5 plus 1 is equal to 7. Then we have to find out the minus of the main diagonal elements, which is the, what is the main diagonal element in the first row? 1 is the main diagonal elements. In this term, we are leaving the corresponding rows and columns. We can find out the minus for the 1. In this way, we find out the minus of the main diagonal elements. The value is 0. Then we are going to find out the S3, that is the determinant A. The value is 36. Now we formulate the characteristic equation, which is the lambda cube minus 7 lambda square plus 36 equal to 0. Okay, from that characteristic equation, we are going to find out the eigenvalues by using the scientific calculator 991 ms. You can find out the lambda values in easy method by using the calculator. Then by using the eigenvalues, we have to see the eigenvalues, whether it is in different values or the same values. There is a different values, that is minus 2, 3, 6. So by using these 3 eigenvalues, we are going to find out the eigenvectors. To find the eigenvectors, we have to use the A minus lambda I is equal to 0 format. In this format, we can expand the A matrix minus lambda into identity, that is equal to 0. In this way, we can find out the x1, x2 and x3. We just form this method by using this characteristic equation method. By using the lambda is equal to 2, in this format we can get the 3 of these equations. 3x1 plus x2 plus 3x3 is equal to 0. Then x1 plus 7x2 plus x3 is equal to 0. 3x1 plus x2 plus 3x3 is equal to 0. So by using this method, we can get the 3 of the equations. But we have to analyze that 2 of the equations are different. One is the same. So we have to choose the 2 of the different equations. x1 divided by, without x1 coefficients, we have to use the x2 and x3 by using the minor method. Then x1 divided by 1 minus 21. In that same way, x2 divided by 3 minus 3. In the similar way, x3 divided by 21 minus 1, we can get the values x1 divided by minus 20, that is equal to x2 divided by 0, that is equal to x3 divided by 20. We just cancel, we get the x1 vector, that is minus 1, 0, 1. In the similar way, we have to apply the lambda equal to 3, second eigenvalue. If we use the second eigenvalue, x2 is equal to 1 minus 1, 1. We get the second x2 eigenvector. In that similar way, we have to use the lambda is equal to 6. We can get the 3 of these equations. In the similar way, by using the 3 of these equations, we have to take any 2 different equations. We can solve the third eigenvector, that is x3 is equal to 1, 2, 1. Okay students, if you have any doubts, call me. Thank you.